Hi, hey, my name is Isaac. I'm the design engineer for Red Phoenix. I just wanted to make a little tutorial on how to design better frames since I've seen a lot of teams don't really understand what it means to have a good frame, like what a good frame is. So I just want to go over a few things. So this is like how most teams start, which is like a pretty basic frame, kind of trying to copy the Tiny Hawk frame and reusing Tiny Hawk parts, which is perfectly fine. So you'll end up with something similar to this, but this is extremely bulky and inefficient, and you don't really understand like why. So I just wanted to go over a few tips that can help you evolve your frame so they start, you know, they go from this to something, like this, which this is an older one, but preferably something like this, which is much, much lighter and much more efficient, as I'll show you why exactly later. So, I just wanted to give how I usually start designing is I usually start with the motor mounts. So sections like this, like these frames, these sections right here, since that's like the easiest to intuitively, start designing. So a big issue a lot of teams have is that when they are designing, they use calipers to measure. I made that mistake when there are good resources online that already have like every dimension available. So for example, you just have to look up, the size of the drone that you want to build. So if you wanted to build a frame for this Tiny Hawk, you would search up 75 millimeter drone schematics, since Tiny Hawks are 75 millimeter drones. For something like a Mobula 6, for a newbie drone Hummingbird, it would be a 65 millimeter drone, so those drones are more compact, looking more like this. That number refers to the size of the wheelbase, so basically how far diagonally the motors are. So you see pretty big size difference. I'll do one for the Tiny Hawk just for ease of use. So if you look at this schematic, you'll see there's the most important dimensions are the size of this hole in the middle. So right here, as you can see, this hole in the middle is 4 millimeters. This is important as that hole needs to be big, because otherwise these motors have like a little like a ring on the outside of the shaft, and if that ring is being touched by any plastic, it'll cause the motors to like slow down, to stop, which can cause a lot of issues. So you want to have that be big. That's a big issue that we had, since we couldn't even tighten our motors tight because otherwise it wouldn't spin. I thought that was just how it was because we were using 3D printing and it wasn't as precise. But no, it was just because of the incorrect dimensions we were using. So so you can see you want it 4 millimeters. So that's what we're gonna do. We'll here Fusion, start with that little center, go 4 millimeters, and oh, we have a circle. Now let's check the dimensions. As you can see, these smaller circles are on a bigger circle that's 6.6 millimeters around the original circle. I'm gonna go here, 6.6. And we're going to place our circles around this outer circle. You also want you also want the holes facing the two of the sides facing inward. So if you're as you can see in this design, they're just facing down onto the sides. But realistically, because sometimes the motor wires are too short, so you want the motor wires facing inwards so you can have the shortest possible motor wire. So you want these two facing the center, essentially. So you can see here, let me show you on the design. You want everything facing the center. So that's the outer circle. The way I like to do it is just make a line here so it'll snap onto here. And let's check the size. So these motor circles are 1.4 millimeters. So I'm gonna put 1.4. Okay, why is that? All right, and we're going to revolve a circular pattern this around the center 3 times to save us some time. So that's done. We have one of the motor bases, but we aren't done with it yet because we don't have something around it. So most people would just like go here, click a circle, and there, you're done. You just extrude this, and you have where your motors are going to screw in. That's what most people would do. However, the issue with that is if you look at how these propellers work, drones work by pushing air down. So this extra area around here is kind of blocking air that could be being used to make your drone faster. So preferably, you would want to do it a little more streamlined. Like if you look at actual drone designs, they're usually not circular; they're more triangular, since that's the best way to like reduce material. There's really no need for that extra material. So you can just make an arc. You know, usually I would just make an outer circle. It's larger and create the arc around there. Let's see. Doesn't really have to be exact. Um, usually I'll spend some more time making it, but it's just to have an idea of what to do. For now, I'm just gonna leave it as is, since this is more of a beginner tutorial. So next is making all four. So a lot of people, what they'll do is they'll make them manually when there's really no need for that. So if you're making a 75 millimeter drone, let's say in this case we are, you want it 75 millimeters from the center, since that's how far they are diagonally, the motors. So we're gonna go here, type 75, and lock it at 45 degrees. Just for your information, you can switch to typing, the size of the length of the line and the angle by clicking tab. So that'll change what you can type, because usually you can only type one at a time. So we'll click enter, and so we have that line. Now we're gonna place a point at the center of this line to have somewhere to revolve. You know it's the center because it has a little triangle. That's the center. So we're gonna go again, circular pattern. Let's select this circle that we did before. There we go. Looks pretty good. These aren't really perfectly facing the center. Usually I would like adjust it and rotate it, but for now it's not really an issue. So that's the start. So let's say a lot of teams get here, and what they do is they just start connecting lines. They start, making it 2D, thinking of it as something 2D. And the issue with that is when you do something like that, not only do you lose strength, you're also using excess material. Like a huge issue with this frame. This frame has been optimized a lot of times to make it so it could actually fly, but it still has a lot of big issues, like how these guards are much larger than the actual propeller, much larger. Like if you look at this is the size of the guard, and this is the size of the propeller. There's so much room here. That's just a lot of added material. In addition, this prop guard is super thick, and it's just like straight plastic. There's really no need for that. It's just there wasting weight. It's extra weight that's not necessary. So in order to avoid that, what you can do is you can use curves. Even if you look at the actual Tiny Hawk design, it's not flat. It uses curves downward. So the way I show how to do curves, the way I like to do it on my frames, to do it the lightest possible. You can see here, pretty light, is that I will extrude this first, extrude what we've done before. But I do. Extrude it, usually to like around 1 millimeter. You can kind of play around, see what works, see what doesn't work. Oh, wait, I just made a mistake. Let me edit this. You can also edit, just you can left click the features. And you don't have to like go back and do it. All right. We're gonna shoot this to 1 millimeter. So there we have the base where the frame, where the drone is actually going to screw into. So once we have that, we can add our prop guards above the actual drone. So that way we can have the prop guards only where the propeller, only at the level where the propeller is, instead of having all this be plastic. You can have it only at the part where the propeller is. And this is just trying to be thin so it doesn't interfere with the air coming out of the propeller, out of the drones. Because you want to have as little material blocking the bottom part of this propeller, or in Tiny Hawk's case, the top part, because the less air coming in, the less air is coming into the actual drone, the less air it's putting out, the less thrust it has. So you want to have this be as like minimal as possible. That also helps with weight. At the same time, you can't have it be too skinny. In this original design for this drone, this is the one from last year, we only had this red part. So it had very little air, blockage. It had really good airflow, but it was really, really skinny. This is actually the one that had the issues with screwing in the motor and all that. We resolved it later, but it's better not to have the issue in the first place. So what we're going to do is we're going to extend a plane above what we already designed. So what this does is allows us to create a sketch at a higher level than what we want. So we know how high the propeller is. You can see here, this propeller is like 14 millimeters above this duct, I believe. I believe it's 14. So I'm going to create a plane. I'm going to offset it. Let's say, I'm going to say 12. Seems like a good point. And I'm going to draw my air ducts. So different drones have different size propellers. Usually smaller drones have smaller propellers. These are usually 31 millimeters. For the Tiny Hawk, they are 40, I believe. So we can look at these designs. These have a 42, so to give a bit of extra room. It doesn't have to be that much. You can use 40, 41, or 41, 40, 40 would be touching. But I'll create a 42 just to have to, err on the side of safety. I'm gonna go here. I'm gonna make a 40 millimeter circle. 40 millimeter circle. And I'm going to do the same thing we did last time, where I make a 75 millimeter line. Put it at 45 degrees. I'm going to put a point at the halfway. And do a circular pattern. You don't have to do the point at the halfway. You can just do half of 45, which is just going to be half of 75, which is just going to be like 37.5. You can just do that instead. I just do that. So that is how big your propellers are going to be. That is like the clearance you need to make sure that these prop guards don't touch your propeller. And prop guards are necessary, so you do need to have them. You can't just make a toothpick drone with propellers out. That's not safe. So, and with drones and school regulations, you do need to have them. So you can just extend this. Let's say we can make it like a couple millimeters bigger than the other circle, so we can have actual a decently thick size, because you don't want it to break mid race. It's better to have a slightly slower drone that doesn't break as often than one that's incredibly fast, but you touch anything, it breaks. So that's what I would recommend. So let's make this 45. This is a little too thick, I feel, but most people, it works well for most people, I would say. Oh, let me just revolt this. There's no need to go and do everything manually if you have these tools that can help you. All right, so there we have our drone, our initial drone. We have a place where the motors are going to screw in, the place where the prop guards are to protect your drone's propellers. You can just connect these. And just use, and this is the best way to do it usually. So just making a bunch of lines symmetric and just put this distance at, let's say, 2. And there we have our connection for the drone. And there we go. So we can just, when we're shooting, we just select this area. We obviously don't select the stick here because this area needs to be fully wide open for our drone. So if you're making a tiny hawk, and if you want to make it like so there's different types of drones. There's drones that have the propellers facing up. These are pull drones. These are usually most racing drones. Tiny hawks are push drones. So if you want to make a tiny hawk and you want to copy it exactly like it is and have it a push drone, just do the same thing. Continue this downward. This will make the build a lot easier. You don't have to deal with any settings. But I would recommend making a pull drone. It's easier to fly and it tends to go faster. But that's just my personal recommendation. My personal recommendation would be to avoid using Tiny Hawk parts altogether since they're pretty slow and inefficient. I would say switch to some other, just buy some motors. You can reuse the Tiny Hawk flight controller and camera. Just buy some new motors and new propellers, and you should be set. But let's just continue working on this. We're going to work on it as if it's a pull drone, since that is typically better. So we have this. If we're making a pull drone, we need a place to put the flight controller. So this won't exactly work for the HC0 since this one has a full stack. It's not gonna work. It's not gonna work. This gonna be more complicated since this one has basically two separate boards instead of like one small board, like on a lot of other newer drones. Like instead of just having like this is the board that we use. This is a Hummingbird V4, and it's really small. It's just one tiny little board, so it's really easy to put on. But these new HC0 Tony Hawks, they have two. So you can just stack them and screw it in, use some spacers. But it's going to be a little more annoying just for people to know. So we have this. We're going to need the dimensions for the flight controller. So it's 36 millimeters from the center to the center. It should be for most tiny flight controllers. So I'm going to go here. I'm going to go 18. Let's say, so usually what most teams will do is they'll just make a little stick, like in this Tiny Hawk frame. You can see I just made a little stick with a little hole in it. It's just a little stick with a hole in it. I don't know if I would recommend this because it breaks a lot. It's really easy to break since it's just a little tiny nub sticking out. But it is the easiest way to do it, so that's how I'm going to do it. So when you're doing this, there's several things you have to keep in mind, like how you have to make sure the hole goes all the way through the drone. Otherwise, it might break the nubs while you're screwing it in. Additionally, you have to make sure that you reinforce it by adding something at the base here, like a little fillet at the edge, since that'll make it a lot stronger. Because just having the stick by itself will it'll break really fast. So I'm just gonna make here a circle. The size of this doesn't particularly matter. I mean, you kind of want a little bit on the thicker side. So let's make it 2 millimeters. Let me use my other drone as a reference because it's been a while. But like on this one, it was 2.5. So I'll make it like a little thicker than that. I'll make it 3. I'll make it 3 millimeters. It's gonna be a little nub, and we're gonna have to connect it to the drone, to the frame that we have. So you can just, what I like to do is you can just, make a line here, make a line here. Oh, not undo that. So make a line there, and we're going to create an arc to go around this so when we extrude it, it's not just hanging off of thin air. So this isn't like an exact science. This is probably a bit of extra material that isn't really required. So like in my frame, I have a couple extra supporting pillars on the side that aren't holding the flight controller, but it's not really necessary. Like you can put a line here and have two separate things support, or you could just make a line here and have it be the only thing supporting. But I would suggest having a few more things since this is the most important support in the frame. It's what's actually holding everything together, so it's pretty important. So I would say having a bit of extra material there isn't really a problem, and it's not something that is obstructing airflow. So it'll just be a couple extra, a little bit, like probably not even a gram of extra weight, probably like 0.2 extra grams of extra weight. So it shouldn't be a problem. Now, if you're trying to get something extremely like precise, yeah, it might be a problem. But for beginner teams, it shouldn't be a problem. So I'm going to copy this on all four sides. Well, before I do that, let me also make sure to put a little circle in the middle. I'll make it 1 millimeter big. So that's where the flight controller is going to go. And I am going to create it. Revolve it. Make 4. There we go. All right, so there we have a prop. These are the prop guards already set, and that's where the flight controller, that's where flight controller is going to go. All right. So there we have the drone frame, the drone motor holders, and the actual prop guards. It looks a little ugly. You can make it nicer. You can design it however you want, as long as you have the basic things required, which are the motor holders and the flight controller holder. And for the camera, you can just put it on top. I tried doing something new when I did this frame. Didn't really work out. Wasn't great. I would suggest just you can even use the same canopy as a Tiny Hawk or any other canopy that comes with your drone. So that's not a big issue. But as you can see, this doesn't have the nubs, since when you extrude, you can only extrude flat one at a time. So what you can do is you can actually go back to the sketch that you did before, and you can just click extrude again. Now you can extrude only the little nubs. So we're gonna extrude it. We don't want it too tall, so I'm gonna make it, let's say make it 5 millimeters. When you do that, the only issue is that it'll have this weird effect where it'll leave all the sketch visible. I don't know why it does this. So there we have our drone. We have a place to put the flight controller. What I'm going to do is I'm just going to fillet these edges so that the flight controller is easier to put on. It also looks prettier. So just like, see it. So just do that, and I'm going to chamfer this circle on the bottom. I'm going to chamfer it out. So I'm going to take it out. Let me see. Hold on, let's make it. Hit 10 or no. Make it decently big so that way it'll be pretty strong. And that shouldn't interfere too much with the installing of the actual flight controller. So that should be pretty strong. But now, obviously, you just have two floating pieces. How do you connect them? Well, what you're going to do is you're going to create a plane at a 45-degree angle to this design. Or maybe let me see. I don't have this. Yeah, we're going to make it at an angle Right, so we're going to create a construction plane at an angle. This way it's going fully through the middle of the drone. If you look through the angle right here, you can see it's cutting the drone in half. So we have our plane. I want to click sketch. So what we're going to do is really simple. We're going to create an arc. We're going to put it here at the bottom, a little bit inside of it, just in case. Sometimes it doesn't, if it's not touching exactly, it won't connect. So that'll be an issue. So just resolving. So we're going to put it here. We're going to create an arc. You want it kind of curved, because that's kind of the best way to do it. Millimeter. That's just so that it's easier to finish. I'm gonna do the same exact thing here. So if you remember, I made this ring pretty thick, so we're going to have to replicate this thickness. As you can see, that's the point where it meets the actual ring of it. If you turn it just like this, you can see the bottom line of it. That's the point right there that you want to put it on, since that's the actual edge to edge of the prop guard. So we're going to put it here. We're going to put it parallel or as close as we can, so that there you can see we have something holding up that prop guard. Click Finger Sketch and you can extrude it. So there are multiple ways you can do this. You can well, let me first, if you see here, I can't even extrude it because I didn't put a line here, so it's not done. So you just get a sketch, line through here. Now we're done. Also, a little down. Let me line through here. That's better. That's fine. So we're going to click extrude. You can either extrude it or you can revolve it. They'll have different effects. So if you, let's say, I'm going to just show for the sake of it, what happens if you revolve it. You click revolve, let's say revolve around this axis and make it 10 degrees symmetric and join. You're going to have this. Make it 5 degrees, it's a little thick. The problem with this is that it's a little thin at the edge, but if you bring it in closer, it won't be an issue, but I prefer to extrude it symmetrically. Click extrude, select this profile, the same thing, go symmetric. We're going to do the same thing, we're going to put it symmetric and we're going to extrude it. I'll see, another issue came here. This is a common issue because we didn't push it enough. Also, if you can see, because we didn't have it lined up at the beginning, we caused some other issues. So it's going to be a little more annoying to kind of put it in closer. But we have to further extend this forward. So let's go back to the sketch. Go to the sketch. All right, so what we did here is we just pushed it back a little bit. So that way, when we extrude it, the edge of that won't be sticking out. So same thing, click extrude. Now select this, select this. That should be good. So this little profile we did here earlier. We're gonna extend it. Let's say 2 millimeters might be a bit thick for most people. Let's make it symmetric. Yeah, 1 millimeter thick should be good. But if you look here, it's going, oh, no, never mind. It's all good. So you're gonna click, actually, you're not gonna click join because join will cause some other issues. You're gonna click new body. And so here you can see you have, let's make it 1.5 since, you know, you don't want it to be too thin. 1.5 seems good. So there you have your new connector to the actual frame, but you only have one and it's only on this one motor. Here you have this. All right, so now that we have one of the arm connectors, we're going to make multiple of them. That's why we didn't combine them at the beginning, because we're going to do this after. So what we're going to do, just going to go pattern, circular pattern, and we're going to revolve it around this axis. This center axis can just be a circle like this. Now we have one motor supported. Now we're going to select these three bodies. So we're going to do the same thing. We're going to go pattern, circular pattern, select, 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 select it along this middle axis, which we didn't do. All right, so we've encountered an issue where we don't have a way to revolve it around the center since we only have one point and we need an axis. So the way to create an axis is we need 2 points. So we want it straight down, so we can't just create an axis all willy-nilly. So what we're going to do is we're going to create another sketch real quickly, and all we're going to do is just create a point here in the center. Well, you can see it's not perfectly aligned. We don't have a way to align it, so we're just going to do the same thing we have. Go to the origin, which is here. Create a 7. Let's make it 37.5. So that'll be easier, and just make it 45 degrees. We have that, and we're going to create a point. All right, done. That's it. So we have our 2 points. So we're going to go to a axis through 2 points. Select this point and select this point, and there we go. We have our axis. After this, we can just delete the sketch, and it's not really necessary. It's a little warning error, but it shouldn't be a problem. So we're going to continue what we were doing before, which is create a pattern, circular pattern, and select these 3 sticks. 4. And that is our frame. As you can see, we have a frame that is much lighter, go much, much faster than the previous frame. This frame could barely fly, barely do anything. If you wanted to create a push drone, what you could just do instead is just do the same thing we did on the top section, but instead of connecting, you would still connect this bottom prop guard, but just don't put this part, just make this stick and connect these 4 and make the part that holds the flight controller on this bottom section. But that is our frame. Thanks for watching.